Hello, this is a short video looking at selected solutions from the homework assignment, the first homework assignment, which is a review of some of the concepts of Stat 1013. So the first question was about z-score. So I want to review the z-score, the normal distribution, some of the basics, just the technical basics, and then also the data types on SPSS. So what does a z-score tell you? Well, here's the correct answer, which I think almost everybody got, but just to confirm that, z-score tells you how many standard deviations. A raw score is from the mean in a normal distribution. So all of those make the answer correct. It also tells you whether the raw score is above or below the mean. So your answer may not have been exactly that. I still would have given you full credit. But from now on, if I ask you the question, what does a z-score tell you? This is the correct answer. Next, find the area under the normal curve between the mean and z equals 1.7. So here we have a normal distribution, and here we want the area under normal curve between the mean and z equals 1.7. So we want this area here. And when we look that up in the z tables, what we get is, I'm just going to erase that little bit. Oh, took out the whole 4. Okay. We get, in the z tables that I've given you, you get the area between the mean and that particular z-score. So when you look that up, this up in the z tables, meaning 1.7, the area you get is 0.4554. Now I've added this extra comment in because I think that is one of the little hidden pieces that many of you may find will help you understand what we're getting when we're getting an area. Usually when we get an area, we measure it in square inches, square meters, or whatever it is. In this case, we're getting a proportion of the total area. So the total area under the curve is 100%. The area here is 45.54% of the total. Next, for a normal distribution of thumb lengths, okay, 1.31 is the mean, so we automatically put that in here. 1.31 is the mean. We want to find with the standard deviation of 0.11. And we want to find the probability that x is greater than 1.5. So we're going to drop this down here. And we get x equals 1.5. We want the probability of x is greater than 1.5. So that is probability x is greater than 1.5, which is the area above x equals 1.5. But we use the z-score, which standardizes it and gives us, replaces the mean with 0, remember that, and then we'll replace the x, the raw score, with a z-score. And in this case, it'll come out to be 1.72, I believe, something like that. So when we look up 1.72, well, it's fairly close to this, the value here, because we had z equals 1.7 here. Here we have z equals 1.72. So the probability of x is greater than 1.5 is the same as asking probability of z greater than 1.72, which is the area above z equals 1.72. The area above, when we look this up, 1.72, sorry, it was 1.727. Let me just correct that here. When we look up 1.727 in the tables, we get this area here. So this area here, 0.4582, or 0.4 5 7 3. So you can look up either one of those because of this value here. So you might have looked up 1.72 or 1.73. Then we have to do 50% minus these areas. So that equals 0.5 minus 0.4582, or 0.5 minus 0.4573. So the correct answer will be 0.0418 or 0.0427. And that's what goes in here. We'll convert it to percent. So I've accepted either one of those because of whether you looked up 1.72 or 1.73. The key thing to this question, though, is the drawing and understanding that when we're finding probability of x is greater than 1.5, we're finding the area, the proportion of the area above x equals 1.5. We convert that to a z-score, and on we go. Now this gave many of you trouble. Sorry, questions 8 and 9. What I wanted you to do was to open up a data set, and I think some of you did not do that. You were just doing it from your recollection of data sets. If you look up an SPSS data set, it will look like so. Or like so. Or like so. So whether you're in variable view or data view, whether the value labels are set on labels or on the numbers. Those are all options. Depending on which setting you're in, you have different clues as to whether the data sets or the variables in particular are categorical, nominal, categorical, ordinal, or measurement. Many of you started using the terms qualitative, quantitative, interval, ratio, which leads me to believe that you were Googling it or looking at other resources, because those aren't the terms that we're using in our courses. Now, if you just look at a data set like this, what can we see? Well, when you see numbers like this is an indication that we have categorical variables. So each of these, sex, CIHC-_3, all of these look to me like categorical variables. Why? Well, because we have a limited number of options. The set of all possible values, numeric values, is pretty low, below 10. So here we see just 1s and 2s. Here we see 1s, 2s, and 6s. So in this case, the 6s will be probably missing values. Here we see 1s and 2s, 1s and 2s, 1s and 2s, and 6s as well. 1s, 2s, 6s, and 9s, and so on. Here we have more variability, 1, 2, 3, 4, and so on. So all of these look like categorical variables to me. So that's one clue. Limited number of possible options for categorical. So let's go back to this data set here. What clues help you be confident that the data is categorical or ordinal in nature? Now, also in data view, so let's go back to if I click on this, what I'll see, so I'm still in data view. If I click on the value labels icon, or if I look here and I see view value labels, so I change the view. Do I see the value labels or not? I can see these turned from numbers to the labels themselves. I've pre-written it for you. Essentially, when you look under clue 1, you have two separate clues. Let's look in SPSS view, in variable view, sorry. When we look in variable view, we look at the same variables here, sex, CIHC-3, and so on. I can look under values, and I see that they're coded. 1 is a male, 2 is female, 6, 7, and 8 are all the missing values. So I can also see it in the variable view. So I'll write that in here. And there are other ways. So oftentimes, people will look under the measure here. But that's not always true, because look at this. Sex, gender is labeled as scale, which is an indication that it's a measurement variable. Well, we're going to change it to nominal. Now, if you wanted to see specifically that it was an ordinal variable, well, we can look here. Male, female, that's not ordinal. Canada, other, not ordinal. Let's look for one that might be. Aha! Excellent, very good, good, fair, poor. There's one that is ordinal for sure. And if we go into data view for that variable, we can see here very good, good, very good, excellent, and so on. So that makes it clear that it's an ordinal variable. Now, how do we look for measurement variables? Well, the same way. We click on this. All the ones that pop up as categorical variables will have labels. All the ones that aren't will look like this. Measurement. Now, why did I say likely? Because if somebody forgot to put the value labels in, you could still get a categorical variable. So I'll just add in another proviso. And look for decimals. So that's precision. Because if you have decimal places, that gives an indication that you are measuring something. Or wide number of possible values. For example, let's take the value labels off. We look at these. Oh, there's very few possible values. 1, 2, 6, 9. 1, 2, 3, 6, 9. 1, 2, 3, 6, 9. Now we look here, 67, 257. So that's very clearly a measurement variable. That's very clearly, this one has the decimals, very clearly a measurement variable. This is a measurement variable as well. Clue 2. So clue 2 is to look at, in variable view, look for scale. So that is sometimes accurate, sometimes not. But you also look for, under the values, if there's no coding. So I'll write that in variable view. And that is that. Thank you for watching.